Hello, so in this video I'm going to show you how to find the sum of a geometric series using the geometric series summation formulae. So here are some geometric series. I'm going to begin with this one. What I recommend you do is first of all write down what the first term is. We call that A, so the first term is 1. The common ratio, that's what you multiply each successive term by. So multiply each term by 2, so that's going to be R equals 2, and N is the number of terms that you want to sum. So N is equal to 10. And then decide which formula to use. So you can either use this one or this one. Now, because R is 2, if I use that one, I'll get 1 minus 2, I'll get a negative value in the denominator. You can use that, but I always prefer to use this one in these circumstances so I don't get a negative value in the denominator. Okay, hope that makes sense. But you can choose either one. So you'll see in my working, I've actually gone for that one there. Okay, and that's purely, as I said, to avoid having a negative value on the denominator. Okay, so here we've got A is 1. You don't need to write 1, but I just have. And then you've got R to the n minus 1, so that's 2 to the power 10 minus 1 over 2 minus 1. The denominator is just 1, of course. So you just need to work out 2 to the power 10, which is 1024. Subtract 1, and you get 1023. And that's your first answer. Second one, so exactly the same process. And hopefully get the idea that these are actually very easy. So the first term is 4, the common ratio. So if you're not sure, just do that number divided by that number. That will always give the common ratio. So it's 3. Then you can check. These are all being multiplied by 3 as we go along. And n is 5, because I've got 5 terms. Now notice this is a finite series. I've just stopped it here. Well, they're all finite series actually. I've just stopped it here. Because I just want to illustrate that you can actually add those numbers separately if you wish, get an answer, and what I'm doing is I'm showing you that the formula actually gives you the same answer until it works. It's not a proof, it's just a demonstration that it actually works. So I'm going to use this one again because I'm going to get 3 minus 1 on the denominator. Okay, so using that one again, here we go, you've got 4, which is A, and then 3 to the 5 minus 1 over 3 minus 1. The denominator is just 2. You can simplify it if you wish. 4 divided by 2 is just 2. And then just work out 3 to the power 5, and then subtract 1, and then multiply it. You get 484. Okay? Now if you add these terms separately, you should get the same answer, 484. It's just, like I said, a demonstration that using the formula gives you the same answer. Hopefully gives you a bit of confidence when you use it. Right, last one. So there's 20 terms. A, the first term is 1. The common ratio R is a half this time because each term is multiplied by a half. N equals 20. This time I'm going to use that formula because if I use this one now, I've got a fractional value less than 1. So half subtract 1 gives me a negative value in that one. So I'm going to use this formula. Okay. So in short, I tend to use this one when I've got a value of R is greater than 1. And I use this one when R is actually less than 1. Okay. So here we go. Substituting it in. You've got A, then you don't need to write it, but I have 1, and then 1 minus a half, put it in brackets because you do the whole fraction to the power 20, half to the power 20, over 1 minus a half. The denominator, of course, is just going to be a half. Substitute all that in. You're going to get a number that's going to get closer and closer to number 2. It's not 1.9 recurring. You might think that when you actually look at your calculator first thing, but there's some digits that aren't 9s, okay? So I'd write down quite a few and then just show that it's not 9 recurring. It's actually 2, of course, if you round it to the nearest whole number, or 2.0, or 2.00, 2.000, okay? That's because this is actually what we call a convergent series, okay? The numbers are converging on 2. If you substituted n equals 40 for 40 terms, it would be even closer to number 2. If you substituted n equals 100 for 100 terms, still even closer. In fact, the infinite series sum of this will be 2. That's coming up in a video later on. Okay. Anyway, the main thing was just how to use these formulae to work out these geometric series sums. I hope you found that useful. Thank you very much for watching. I'll see you again.